So when we look at exponential functions, we know that there's this relative rate of change that's consistent. But what that relative rate of change is depends on whether we're talking about, say, a year, a month, a day. We would get different values for that relative rate of change. Now, there's one limiting case where we can ask, what's the continuous rate of growth? What's the continuous rate of change for this function as I go along? And so to deal with this, I want to look at compound interest. And so when we look at interest, we say we get some proportion back of our original investment. So let's say we started with $1,000 and we were getting 12% back. Well, after 1 year, we start with $1,000, we should end with $1,120. That's when it's compounded annually, which means just once. Now, if we compounded twice, so compounding meaning that instead of one chunk of 12%, we get two returns of 6%. So, you might say, oh, well, 6% and 6%, that gives me 12%. Not quite. So when we do that first 6%, we get an extra $60 on our original $1,000 investment. And then at the end of the year, when we get that extra 6% of $1,060, we end up having $1,124 in the end. So that was because we took 6% of something that was, well, bigger than the 1,000. And so we end up getting that extra $4 if we were to compound more frequently. So you can say, hey, well, maybe I can get a lot more money if I, start compounding more and more frequently. And you do see an increase if we compound quarterly, so 4 times per year, we get 1126. When we compound monthly, then we're getting, taking that 12% and splitting it into 12 chunks of 1%. And you see that we get up to about 1,127. And as we take the limit of compounding more and more frequently for the same total, when you add the percentages together, you still get up to 12%. You get this continuous rate of growth, or this continuous growth that it maxes out at some point. So you don't keep getting extra, you don't keep getting a lot extra as you go to finer and finer gradations. But you do, have more than if you just compounded the one time. So in this case, the limit seems to be somewhere around 1,127 and a half, rounded. Now, when looking at continuous growth, and if we want to start with this mathematically, you can start with 1,000, you can start with 50, you can have, 12% interest or 5% interest. Let's start with some idealized situation. Let's start at 1. And look at 100% growth and go through that same process of, well, what happens when I compound once, twice, 4 times, 12 times, or continuously. And if you do that, what you find is that your 100% growth, starting at 1, gives you 2.718, and then there's ... When you do this meticulously, this ends up being a number that doesn't repeat. It's a transcendental number, or irrational number, sorry. And the much like pi, it's a number that has an infinite, the decimal places keep going forever. I don't like using the term infinite number. It just doesn't quite work. But I do like saying that, hey, e is very close to the number 3, and so is pi. So, hey, there's a relationship there between e and pi. But e is representing this continuous growth rate of 100%. And now to do this, you need limits, and we're going to get this later on. Though if you wanted to try this on the spreadsheet, you can show for yourself that you get this 2.71828. Though I think if you were using Excel, which I think you have access to through Mount A, there's a max of just over 1 million rows if you want to break this down. So using whatever method you prefer, I want you to find the number e on your calculator. And so that would be the first one. The second thing is to answer the question, how would you solve for x given these two different equations? So we know the answer is both the same. So 10 to the power of x is 1,000. So what is x going to be? My answer is 1,000. My y value is 1,000. Now, e to the power of x, e is something that helps us understand continuous growth. It's a number that's a little bit less than 3. My x value in this case is going to be different. So how would you find that value. And I have a couple of hints here. If I write down log of y without giving a base for the logarithm, then I know that's base 10. And if I write down ln, or we pronounce it ln of y, that would be log to the base e of y. And I've also given the definition of logarithms right there. So go through those questions, and then we'll come back for one last video.